In this example, we have a company owning two petrol stations, A and B, along a main road. Total daily sales in the same week for A and for B are summarized in the table below. Our first task is to find the product moment correlation coefficient for this data and give an answer to three significant figures. So we go to the calculator. If you've still got data, a quick way of getting rid of it is to go into Option, select number 2, Editor, and then 2 again, delete all. So let's carefully enter these values. I'm going to enter the X coordinates for A and the Y coordinates for B. Okay, I'll check those again in a moment. Now for the other values. Add that all in. It's always worth a quick check, run through them, make sure you haven't made any typing errors. Once that's done, Option, Regression Calc, and there is our value of R, minus 0.664 to three significant figures. In part B, we're now going to carry out a hypothesis test. Test at the 10% level of significance whether there is evidence of a negative correlation between the sales for stations A and B. State your hypotheses clearly. When a question like this, our null hypothesis is always that there is no correlation for the population. This is just this is just sample data, and R is the correlation for that sample data. This symbol here, rho, represents the correlation for the whole population, and this is the symbol you must use in your hypotheses. Now, because we're testing where there's evidence of a negative correlation, that means our alternative hypothesis is that rho is negative, which makes this a one-tailed test. So we're not splitting the 10% across the two tails. There's only one tail, and it's got 10% level of significance. So our value of R minus 0.664 for a sample of size 1, 2, 3, 4, 5, 6, 7, is that strong enough evidence of an overall correlation between all the values for A and B, not just this particular sample? So this is where we turn to the table, and I've done a little screenshot of the table here. It's a much bigger table than this. We've got 7 pairs of values, so our sample size is 7. Don't make the mistake of using 14 for the sample size. It's how many pairs of values is what we're looking for. So here we have 7 pairs, n is 7. 10% because it's a one-tailed test, so this column, 10% column, n is 7, and we get a critical value of 0.5509. Because we're testing for negative correlation, then our critical value is actually minus 0.5509. The table only prints the positive versions. If you're testing for negative correlation, you need to know to put a minus in front of it. So that's our critical value. So the rejection region is anything less than minus 0.5509. So just to make that hopefully perfectly clear, if the correlation from our sample is stronger than minus 0.5509, and when I say stronger, I mean closer to minus 1. So if it's in there, then we will reject the null hypothesis. Of course, the value we got, minus 0.664, is in this region, minus 0.664. So yes, that is strong enough evidence to reject the null hypothesis. So this is a significant result. So we can reject the null hypothesis and conclude that at the 10% level of significance, there is enough evidence to suggest a negative correlation. between total daily sales for stations A and B. Make sure you mention the context of the question in your conclusion.